All right, so why don't we'll start with some introductions, and then by then, if anybody else needs to join, it should be on. We don't want anybody to miss anything. So my name is Don Milstein. I'm president of Vitrek. Really appreciate everyone taking time to join our session. The session will be on Hipot testers and best practices, both from how to use them, safety test setup stations, as well as how do you do compliance testing. We'll kind of take you through the full gamut. And highlight, along the way a little bit about Vitrek as we go. But this is really more of an educational session. Presenting today will be myself for the very beginning, and then Chad Clark, and our contact information is on this page. Chad Clark, our Vice President of Sales. Chad, go ahead and say hello to everybody.
Will not be recorded.
Oh.
Hello everyone, welcome. I'm glad you were able to log in. And hope you guys enjoy the presentation you have.
So what we've decided is you can see us now. You can see that we both work real clothes. We're not in our pajamas or a hoodie. But once we start going, we'll just turn off the screens. It's just a little easier and not distracting to anybody. And to be honest, Chad has a better face for this than I do, so you don't need to see us. So we'll do it that way.
Yeah, face for radio.
That's right. But again, welcome. Really appreciate everyone taking time. Obviously, this is a crazy time, not only across the United States, but across the world with this COVID-19 epidemic. The thing we normally try to do are these type of meetings in person. Well, that's not going to happen. So we're looking at other venues of how to educate and share thoughts and have interaction with our customers and hopefully educate you. So this is a webinar. We'll be doing quite a few of these over the next couple of weeks until we can all get back together. I'm happy to say everyone, and hopefully, our families at Vitrek, everyone's healthy and have done everything they can to be safe. And I hope that's the same with everyone on this call. If you don't mind, if anybody's got their phone, put it on mute. It'd be a little easier just in case we have any background noise. So yeah, I really want to thank all of the people at H2O Degree. I mean, for Vitrek staying healthy and really working, keeping social distancing. We were able to keep open our facilities. We'll talk about that in a second or two, and continue to service our customers. And you can't start one of these without thanking everyone on the front line, both the doctors, the nurses, the trash people, the grocery store clerks, and everything else, and all of you. Right? I mean, you're still working. So that's a good sign, and at some point we get back to somewhat normal, which would be great. So with that, Chad, just go to the next slide, and we'll talk about some one or two little ground rules. The goal here is 45 minutes. We'll stop periodically for questions, and what we'd like you to do is mute your phones now. Would be great. And as we come up to these little slides where there's a question, you can either unmute your phone, but at all times you can use a little chat feature in the corner. You'll send in those questions, we'll be monitoring them, and then we'll be able to answer those as we hit these little question areas. But we'll also open it up just in case anyone's got a burning question to go over. And with that, I'll start off. So just real quick overview on Vitrek. Really industry leader, been in the test and measurement industry for over 30 years. We're headquartered in San Diego, California. We're American made, so everything's built here. Our manufacturing plant, our calibration labs, our test facilities, and all the engineering, sales, marketing is all done there. But we are an international company. We have, when we say serve over 30 countries, we have actual sales representation on the ground in over 30 countries. Yet we sell to hundreds of countries throughout the world. So we're truly an international organization, but everything is manufactured in San Diego, California. Our product lines, which we'll go through, but we kind of have a diverse group, right? Everything's in the test and measurement area. Hipot testers, which is the focus of this PowerPoint. We'll also talk about cable tests. We have a power analyzer product, which we'll talk about. High voltage meter, DC load. One of the key features is our facility is ISO 17025 accredited for calibration. So not only when the product goes out the door can we calibrate and get certified, but as you continue to use it over the years, at any time it can be sent back to our lab to do it, or obviously you can use a third-party lab. But that, just another piece that we take our facility to the highest level we can in our industry. When you think about the industries we serve, it's kind of diverse, right? We're into semiconductor manufacturers, LED lighting, aerospace, military defense is another big area, motors and drives, pretty diverse. And what really brought home during this kind of crazy time, epidemic, we were getting emails and calls from our customers saying, hey, we're critical infrastructure, right? We're a defense contractor. We're making medical equipment. We're making ventilators. We're making whatever. We need you to support us. We need your test equipment. You have to be open. And I'm proud to say that our team stepped up to the plate. We figured out how to get our employees from the manufacturing into the facility, gave them proper spacing, took definitely the hygiene that we needed to do, and sanitizing the equipment and everything else, and stayed operational and supported our customers. So it's important that we're all part of the same ecosystem to do that. What I like to do is kind of break down on the next slide the customers, right? We fall into a couple major buckets: consumer products, whether it's Sub-Zero making refrigerators, or GE making toasters, or obviously computer manufacturers and printers is a big part of our industry, right? These consumer-oriented products. The other big category is the commercial industrials. Anybody doing any kind of big electrical infrastructure manufacturing, or anything with the medical field, like a Philips Healthcare, is another key customer. Last 5-10 years, a little longer, has really been a big push on sustainability and green market sectors, whether it's LED lighting or solar panels, electric vehicles with companies like Tesla and BMW and others. We're definitely a strong market, and that's driven by the higher usage of energy and the quality that's required there. And then I'd say the last big bucket is testing and compliance, whether it's at a lab within these companies that we just went over in the first three in their actual R&D lab, or truly third-party labs like UL, CSA, TUV. We do a lot with government labs, whether it's the military labs or Lawrence Berkeley labs. All of these areas are using our products for testing and compliance. And in a lot of cases, we have many countries using it as their standard when they test other people's products. So pretty diverse, and it's one of the good things. And we can see from the people attending this conference, you kind of fall into various buckets here. So that was also a good sign. From Vitrek's products itself, today's feature will focus on the Hipot tester, which is, really your typical electrical safety tester, making sure we're not shocking anyone, right? Pretty simple. But our market also expands beyond that. In the power analyzers, we have a full suite of power analyzers used to measure electrical power, what the efficiency is, both in the R&D lab and sometimes on the production floor. Really a high resolution, highly accurate power meter. Another area is high voltage meters. We do a lot of testing where these products go out to customers looking to test high voltage, whether it's in a lab space or from a production line standpoint, or really an R&D lab. The highest level voltage, very high-end accuracy. And then our fourth more recent product is a DC load, and that is used to test products for power supplies and batteries, really looking at the full gamut: voltage, current, power, resistance, whatever else. So I wanted to show this, not to by any means be a commercial for Vitrek, but just to show you that when we talk about Hipot testers, we're also able to bring in all this thought leadership we have in these other areas, and really what sets us apart as a manufacturer. So with that, I just want to see if there's any quick questions, and we'll also transition to Chad Clark, Vice President of Sales and Marketing, been with the company over 11 years, has a ton of knowledge and be very effective in presenting the next area for you. And any questions? I don't see anything on the chat. Anybody, if you got a burning question, hit the mic. And if not, we'll kind of roll to the next screen.
All right, Don, thank you for the intro there. I want to introduce myself again. If you missed it in the beginning, Chad Clark. I'm going to run through this, and I'm happy to answer any questions you guys have. If we can't do it live, we'll do it at the question breaks that we have scheduled here. So everyone's here because obviously you want to learn a little bit today or a little bit more about Hipot testing, and usually it's specific to compliance testing. You know, not a lot of people are doing this for fun as a hobby. This is typically a requirement. It's been put upon you to be able to ship your product, whether it's within a specific geographical region or just in general. So the big question is Hipot, and what is it, and where did that funny word come from? So potential is another word basically for voltage. You're looking at the difference between two things and the voltage there. So Hipot is a contraction of high potential. And basically what it is a test where you're going to put significantly more voltage, let's say 10 times more than a circuit would typically see, but not across the circuit. You're applying voltage to the circuit, and then you're measuring that leakage to ground or chassis. So it's really an isolation test, just to verify that there's sufficient insulation and isolation. And that can be plastic, air, ceramic. There's all kinds of different insulators out there. So applications, there are, you know, any number of applications. It's really limitless. And our testers don't really know the difference, whether you're connected to a toaster or a printed circuit board or a billion-dollar airplane. At the end of the day, the measurement is always going to be the same. You're going to have two conductors separated by an insulator. We want to verify that there's, you know, near zero current flow, or the amount of current that's flowing between those two conductors is not more than what would be expected. If there is more, that could be because you have compromised insulation. Things could be corroded, contaminated, or it could just be designed wrong. You know, maybe you designed something and they built it in inches instead of millimeters, and all of a sudden you get it back and it's just straight wrong. That happens too. You want to verify that there's also the proper surface creepage, which is like linear distance. Sometimes instead of traveling through the insulation, it's easier for the electricity to go around the corner and travel on the surface. There could be some dirt or some moisture there that helps it creep along. And that's something that you're also going to be able to catch during one of these tests. All right, so here's the big question. So obviously, you see these labels all over the place. UL, CSA, CE, TUV, and there's a handful of others that we have listed. These will typically be on products, and there's going to be a 4-digit number next to them, and that verifies that product has been tested to a very specific set of standards. You're going to have a 100-page standard that goes through the safety all over the place, from balance, weight, RF, all kinds of things. And there's going to be one section there that's electrical safety, and that's really the part that we specialize in. That is where you're going to have to use a Hipot tester to perform those tests. All right, so the most common of the compliance tests, which is going to be the Hipot test, also known as dielectric withstand, can be AC or DC. Voltages are typically going to be 2 times line voltage plus 1,000, but they really can be anywhere from 25 volts up to 30,000 or even more, just depending on the voltages that the product is used at. Test times can range from really 100 milliseconds if you're doing quick component testing, Typically 60 seconds is very common. Some people like to stress their components, long term, and maybe do a long-term study on it. 60, 90 days, 6 months, or a year. That's not uncommon either. But ultimately, you're going to be measuring that current between the two conductors, and that is going to be represented in microamps or milliamps. So the other common test is insulation resistance, DCIR. Some people might call it a Megger test or measuring, because the Megger company kind of made that test famous. It's almost always a DC test, although it doesn't have to be. The voltage levels for insulation resistance are typically going to be lower than that of a Hipot test. In a Hipot test, your goal is to stress the insulation, possibly to the point of failure. And in an insulation resistance test, the objective is to quantify the value of the insulation. So we're actually going to make that measurement, convert the current into ohms, simply via Ohm's law, and we're going to represent the value of that insulation. It could be 100 megohms, it could be 100 gigohms. You're able to set limits around that. 100 megohm is a very common requirement, but at the end of the day, instead of measuring the current that's flowing between the two conductors, we're going to quantify the value of the insulation, and that's what an IR test does. All right, so another very common compliance test, there's basically two ways to do it. It's going to be a ground bond or a continuity test. Both of them are measuring the same thing. You're going to measure the resistance from your chassis to your earth ground pin. The reason you do this test is to verify that the chassis is properly bonded, and that if there was a failure, you could pass sufficient current through that earth ground lead to trip a circuit breaker. On the bottom end, it's always going to be a 4-wire Kelvin measurement. And this is kind of this graphic here depicts a situation where you could have 100 conductors. If you used a regular DMM with maybe 50 milliamps of source current, you can make this resistance measurement, and it might be within the limit, let's say under 100 milliamps. But if you were to do a ground bond test on it, and if you were trying to pass 30 or 40 amps of current across that single remaining conductor, I know this is kind of exaggerated. Typically, they might only be clipping a few strands when they're stripping the wire, but in this case, we're only left with one. You're going to stress that remaining strand so much it's going to heat up. It could even burn open. But at the very least, the resistance is going to increase as the temperature increases. So you can kind of think of a ground bond test as being similar to a Hipot test in the fact that it's stressing the conductor to verify that it can flow the current necessary, where in a Hipot test, you're stressing the insulation to verify that it can isolate. All right, so this is another test, not as common, but there's going to be a handful of standards that require it, and this is something we can do with the 95X. As you know, although there are standards for wiring, you could have an outlet that has a floating ground. Oftentimes, you will have line and neutral crossed in an outlet. You're supposed to have, the bigger in North America NEMA 515, the bigger slat on the left is supposed to be neutral. The one on the right is supposed to be line, which is going to be a smaller gap. Sometimes those are crossed. So some of the standards require like single fault testing. So let's pretend ground isn't there. You put the 95X in where the ground is supposed to be, and you measure that current flowing to ground. It's kind of a single fault failure test, and that's something that we offer. Does anyone have any questions at all over the common types of compliance tests that you would get in a multi-function Hipot tester.
And Chad, real quick, this is Don again. There's definitely, just make sure everyone has their microphone on mute. I think there's one or two little bit of background noise. If not, Susie, just kind of knock it off. Thank you.
Okay, moving on. So Vitrek basically has two mainframes of Hipot testers. The V7X series is shown here. It is a great production line tester. It's more compact than our other line of testers. It's a little less powerful, but still sufficiently accurate. It's going to offer AC/DC Hipot, depending on the version that you're looking at, but it can offer AC/DC Hipot, insulation resistance, ground bond, and continuity. Pretty much everything that we talked about before, minus the ground leakage test. People really enjoy it because it is so easy to use. It has a color touchscreen. You pretty much select a field, an editable field pops up, you make your change, you save it, and you go on testing. Most of the interaction here is between the start and stop button. The 1 microamp resolution's sufficient for medical testing and things like that. It's also made here in Poway. And then the other, and then this is basically the way that you connect them. On the front panel, this is a common question. Okay, I have my Hipot tester, now how do I connect it to my DOT? And we've kind of shown it here on this graph. So you can see a Hipot or IR test is always going to be from the high voltage to the return terminal. Continuity is going to be from the return terminal to the continuity source terminal, and that's always going to be a 2-wire measurement. And then ground bond is a 4-wire Kelvin measurement, where you're going to have the continuity plus terminals on one side of the circuit and the continuity minus and ground bond minus terminal on the other side of the circuit. The 4-wire measurement allows you to null out any voltage drop in the test leads, which is very important when you're trying to make precise measurements, especially those below 100 milliohms or so. All right, and then the other family of testers that we have is the 95X. This particular mainframe is very flexible. We have multiple voltage output options, 6, 11, or 15,000 volts DC, 6 or 10,000 volts AC with an external option up to 30,000 volts. If you need speed and precision, this is definitely the top tester on the market. We're able to do test times in 100 milliseconds or less, depending on voltages there. The leakage current accuracy is in the hundreds of pico. The resolution is 100 picoamps, and we're good for total accuracy measurement of a nanoamp and a half or 2, which is really kind of unprecedented for most Hipot testers. This accuracy also allows us to do IR testing to about a teraohm in this product. So this is one of my personal favorites. It's the 964i. It's a blank mainframe chassis that we can control 64 individual single pole, single throw relays within it. This box can be put between a Hipot tester and the device you're testing. It allows you to route the signals to multiple points across your DOT. We also have customers that are using it with our power analyzers to measure different points at different times. We have customers that are using it with our high voltmeter, obviously to monitor multiple different things at the same time, or to use one meter to measure a dozen devices or more. This is kind of a custom configured product. Reach out to us if you have questions about your application, and we can make recommendations and kind of set up a wiring diagram, an internal diagram for you to use. The voltages are all over the place, from 2.5 kV or 3 kV AC and DC up to 15 kV, and then we can also switch ground bond to 70 amps, although it's typically only 40. You're not limited to even using Vitrek products with this. We have people that are using LCR meters, different sources, all kinds of different things with our 964. In that case, it would be controlled externally via GPIB or RS-232. If you're using it with one of our Hipot testers, you can do a direct control from the tester without a computer. All right, so this is a newer product. We leverage some of the 95X infrastructure to make a lower noise, very high accuracy, and high voltage tera-ohm meter. So most IR meters out there are going to stop at 1,000 volts. You know, you're going to have 500 or 1,000 volts, and that was fine. But we were constantly running across applications that are higher and higher in voltage. And now we can offer a solution for very high precision. You know, typically this is going to be used for 100 gig ohm requirements or more, up to 10,000 volts. Does anyone have any questions about any of our product offerings or the capabilities? Give you a second. I'm not seeing anything here. All right. We'll go on to the next slide here. So test procedure. So you order a tester, UPS drops it off, take it out of the box. Okay, what do I do now? Very common question here. So the answer is it depends on your DOT. So you have a class 1 product that's going to use a 3-wire power cord with an earth ground, and then there's a double insulated product, like a blow dryer, for example. That's actually a bad example. How about a vacuum cleaner? Because this is in the picture. Some of those are double insulated, and you're only going to have line and neutral, and it relies typically on a plastic exterior. So you don't really have a way of easily connecting to chassis ground in that situation. But remember, to do a Hipot test, you still need 2 conductors with an insulator in between them. So you have to kind of create that second conductor in some situations. This is also common for photovoltaic cells when you're testing them. You're going to connect to positive and negative in that case, or line and neutral in a line powered application, and submerge it, wrap it in foil, wire brushes. I've seen all kinds of different things to simulate the areas where a person could touch and be able to complete that circuit to measure the current. Obviously, for a grounded cord, it's easier. You're able to use an alligator clip on the earth ground pin, or one of the boxes that breakout boxes that I can show you later. All right, so types of failures. You can fail leakage. You go in there and you set a limit, and it might be 5 milliamps, and you connect your product, and for whatever reason, whether it's capacitive or resistive or both, you're 6 milliamps. Okay, you're going to fail, and we got to figure out why. Is your setting wrong, or is your product built wrong? You can also have a breakdown, which sometimes is confused with an arc. It kind of just depends on the way you use the word, but sometimes there'll be an audible flashover. You'll hear it break down, and that's a very easy thing to detect. With the V7X, we have breakdown only mode. You're not required to set a leakage current limit. You just say that I do not want my product to break down, and we take care of it from there. And the other thing is arcing. So we have a special circuit in the testers that are really looking for that high frequency that's present when there is a flashover. When there is an arc. You can set that limit in both amplitude and duration, and we can cue in on that and detect and flag a unit as a failure for that reason. All right, so here's some common standards. 61010 is a very common one. That's the one that applies to us. You have different standards for luminaries, UPS systems, household appliances. All of these have a different standard. The tests are similar, yet different, depending on what products you're looking at. So some of you guys might find some of these numbers familiar. Typically, they're harmonized standards, so that EN could be an ISO, it could be a UL, it could be an IEC standard, and you're going to find the verbiage to be very similar throughout all those different standards. All right, so you have this test. It's broken up into multiple parts. Typically, you're going to have a ramp that you can define based on time, or in some cases, current, if you wanted to charge at a specific current. Then you have the dwell time. Dwell time is how long you're going to hold your device at that test voltage. And then obviously discharge, which is either going to be fast, which is the normal setting, or you can have a ramped discharge if you choose. We can apply different limits at different parts of the test. And importantly here, we can also have a delay. As you turn the corner from ramping to dwell, you're going to have, especially in DC, you could have very high charge currents right here. Then when we stop charging, you could actually have current reverse slightly or go to zero. And then what you really want is that current to stabilize and then take an accurate measurement. So we can ignore any noise that happens right in here and then get a really solid measurement result and hold your test requirement, make it applicable right here. So one thing that we can do is seamlessly measure resistance depending on the mode that you choose, from near 0 ohms all the way up to tera ohms. On the bottom end, you're going to use ground bond, and that's going to get you up into the couple hundred milliohm range. From there, you're going to use the low ohms function, and that will measure up to 100 or 150 kilo ohms. And then beyond that, you're going to switch to insulation resistance, and that will allow you to measure up to as high as 50 tera ohms and then 980. So it's really, really seamless, and there are no gaps where we cannot set a limit and be able to make a determination and fail a product. So that is convenient for us. So this kind of breaks down just how to do a 4-wire Kelvin measurement. Again, this is important, especially with low resistance measurements, as you null out any voltage drop in the test leads automatically. When doing an AC ground bond test, you can see that we have multiple different limits that you can apply at different times, a lot like you can with our Hipot tests. This is a unique feature if you are trying to make a very precise ground bond measurement. So do you have any questions about the types before we get into workstations here?
Hey, Chad, one point I forgot to say in the beginning, the presentation will be emailed out to everyone attending this. I should have said that before if you've been scrambling writing. It will be emailed out, so you'll have a copy. I know there's someone asked that question. And it'll also
don't bother taking notes.
It's also being recorded, so you'll be able to go to our website.
And most importantly, don't be afraid to reach out to us and ask a question. Maybe even if it wasn't covered in this, or you think it might have something to do with this subject, we're more than happy to try our best to help you out. All right, so workstation design. So as you guys know, there is a potentially lethal voltage that's applied with these Hipot testers. So it is important to use them properly. There's no replacement for an experienced, trained operator, just like safety and any other thing, whether it's a car or a knife. you want to use it in the right way. We've developed a bunch of different devices that can help you safely use the product, and we're going to go through some of those right now. So the first one is all of our testers have an interlock, and what that interlock does is it's basically just looking for a contact closure on the DIO port, and you can connect that to a switch. It could be a micro switch, it could be a light curtain. It's not picky about what kind of switch it is, but the whole idea is that you use that switch in an intelligent way to shut the tester down if it opens up during the test. In this situation, let's say we have a DUT over here and we don't want the operator touching it during a test. Maybe it's easier for them to hold the wires onto a contact point, and you found that they're kind of cheating because the operators found an easier way, and you want to force them to not be able to do that. Okay, so what we're going to do here is we're going to wire these two switches in series, and you have to have both of these green switches, these palm switches, closed. So the operator would have to put their hands on them, use the foot switch down here to initiate the test. If during the test either of those palm switches became open circuit, we would abort the test. You know, it definitely can make testing slightly less efficient, but going to some effort to put in some safety restrictions is certainly worthwhile. So here's another option. You just put the whole DUT in an enclosure. So the enclosure is, you know, isolated and grounded, and on the lid there is an interlock switch which would be wired to the DIO. So in this case, what happens is if you lift up the lid during a test because you want to touch the high voltage so bad, it aborts. Here's an example of what one looks like. You know, they have nitrogen lifters on the side, so lifting the handle is very easy. Above, I believe this is an option, but you can have a pass-fail light as well as a testing light. At the end, this is probably the safest option. You know, anyone can figure out how to use this. It's very foolproof. I highly recommend, if you have a device that would fit inside these enclosures, you know, to take advantage of them. All right, so back to the connections. So yes, you can take alligator clips and you can clip the alligator clip to line and neutral. You can clip another one to ground. That works. There's thousands of people out there doing it. We're totally guilty of doing it at the factory at Vitrek, although not in production, but for some testing and things like that. The downside there is you do have exposed high voltage, as well as inconsistencies in the contact between the alligator clips and the end of the power cord. If you use something like this is the TLUP adapter. It allows you to make half of a ground bond measurement and an entire Hipot measurement. Your power cord plugs in there, you take another alligator test lead and you clip that onto the chassis of your device, and you've made a safe, reliable connection that's also going to be consistent. And you're able to use a variety of international power cords with this box. If you choose not to use international power cords, this is the way to go. If all of your products are the NEMA 515 connector, go with this option. It obviously works better to use a designated outlet for your power cord than one that is more flexible and versatile. So there you go. So not everything has a power cord, obviously. Let's say maybe you're testing a printed circuit board or something like that that has a trace that you want to make contact to. For that, you need a probe. You wouldn't even be able to use an alligator clip. This test pistol style probe is probably your safest option. When you pull the trigger, the probe extends and you could use that with the hold steps or pause steps in the unit to make contact, maybe even a foot switch if you wanted to make sure that the operator was making contact, and then they could press the foot pedal and start a test. Highly recommend this product for anything that you cannot clip an alligator clip to. So here's a safety checklist. This will be included when it gets sent out. Ultimately, number one right here is just don't touch the DOT. Although the chassis of the device is clamped to ground via the return lead, anything crazy could happen. The lead could fall off, who knows? So when in doubt, just don't touch it. Try to make a habit of using the interlock with your test fixtures, and make sure the high voltage light is out before you touch something. As Don mentioned earlier, we are an ISO 17025 accredited facility. We're accredited by A2LA. Your own quality standards are ultimately going to dictate what you need for calibration. At minimum, everyone needs, a 1 or 2 year NIST traceable calibration interval, but we also do offer these cals. The greatest thing about it is you can order a product and it's going to come immediately with an accredited cal if you choose to, and you can start using it that day. Years ago, before we were accredited, we would have to manufacture the product, ship it to a third party. They could have it for a day or two. Maybe the unit would go directly to the customer, then they would have to send it out to the cal lab, and ultimately it created as much as a 2-week delay before our customers could start using the product. So everyone appreciates this. This is the last thing we're going to talk about is, so you've gone all this effort to create a manufacturing line, manufacturing system. Now, how are you going to prove that you tested that product? Yeah, you can test it, slap a sticker on it and ship it, and that's fine. But some people want to go to the next level. They want to have serialized record keeping that the product's been tested. And this is where Quick Test Enterprise comes in. So this resides on an SQL database. You can use it across multiple different stations, even in multiple locations. And what it allows you to do is pull a test sequence, load it into the tester, load it on the computer. This can be pulled from the barcode or serial number of the unit, run the test, save the report, and actually have some traceability so that if there was an issue even 5 years down the road, you can go, yeah, serial number 123, we tested it on this date, and we used this tester, and that was the time, and that was the user. And you really have all the information right there in front of you, and it's accessible. So we highly recommend this. So between Quick Test Enterprise, safety enclosure, and one of our testers, maybe like a TL-UP2 and an outlet, you really can get a full solution to your compliance testing. And that's what we offer. I guess we'll open it up to questions one last time.
So Chad, there's a question about annual calibration process. Obviously, the customer has to ship the tester back to Vitrek, and the question is about the turnaround time. It's kind of
so we obviously offer calibration. Our turnaround times are great. Unfortunately, the calibration does have to be done at our facility. If you're shipping it, it could add some time. There's nothing specific in any of our products that requires them to come back to Vitrek for calibration. If you have an internal cal lab or a mobile cal team that comes in and calibrates all your equipment in your lab, definitely check with those guys. It's likely that they could cal the equipment, and you wouldn't have any issues, and you'd have minimal downtime if that's most important for you.
But in the end, most of the time we're turning them around in a day or two, something to that effect.
Yeah, we try to have the unit for 48 to 72 hours at maximum. If you need it in 24, we can definitely do that. In some cases, same day. the best thing to do if turnaround time is your #1 priority is to contact us ahead of time, let us know when it's going to arrive. We will, put it into the queue and make sure we can get it out quickly.
And pretty much as far as costs for calibration, it's just a one-time fee. Right? I mean, what's kind of a ballpark on that?
Yeah, so depending on the product, it's $150 to a few $100s, depending on the functionality of the product and what calibration you go with, whether it's a NIST traceable cal without data or an accredited cal. Right. We try to be competitive in our calibration prices. We want our customers to send the units back to us. At that time, we can take care of anything, buttons, little issues, things that wear out, update the firmware, things like that.
There's another question about capacitive discharge from the AC inlet.
Yeah, so neither of the V7X or the 95X perform the CDC, the capacitive discharge test. It's kind of a neat test, although it's not super common, where if the product was to be unplugged, at the top of the line cycle, how much energy is there and stored within the product. It's something we're aware of and we can help you guys out with.
Anybody else have questions? Feel free to unmute your mic if you'd rather just do that and throw something in chat or myself, and I'll just pass it back to chat.
Can I ask something?
Sure.
It's about the safe test environment that you showed earlier. Does it have any special requirements, or is it just, well, how it looks? Nothing special. Aluminium rams and I guess glass or plastic.
Yes, so in the enclosures, any of the metal components are grounded in the enclosure. The rest is acrylic. There's really no special requirements there per se, but you do need to take in account, creepage and clearance. Make sure that your product is going to fit within the middle of it, not be pushed up against the side, things like that. You certainly wouldn't want the metal chassis of a unit making contact with the frame of the unit.
And also one more question about capacitors. We bought the 951 a few months ago, and we started testing the capacitors that we made, especially the breakdown voltage in CMOS. But we couldn't find the industry standard how they measure it. We only know from some faculties that told us you measure it like this. So do you have any recommendation or some paperwork how to measure, how the big companies do it? Because it will be a lot of help.
What standard are you testing to? This is something that I'd be more than happy to look into. I think it might be best just to take it offline and maybe via email or something like that, we can get that documentation to you.
Okay, that will be great. But the short story is that we make high voltage capacitors and we want to test them properly. But I'm not so satisfied with how the other faculties told me that they do it, because I think it's just, well, it's not the industry standard, so I don't agree with them fully. So
yeah,
well,
a lot of the manufacturers that I've worked with that are making caps really only test them for breakdown. And I'm not aware of a standard that is specific to testing capacitors. It would probably fall under some general component standards. But I'll poke around.
Okay, because I was mainly concerned about what options do you use and what do you have to look for, because we tried measuring some capacitors that have a breakdown voltage of 50 volts, but with the methods that other faculties told us, we get a 4K voltage on them, which is a big difference. So we are not sure that we are doing it properly. So I wanted to check how the other big companies do it, if you understand.
I understand. I mean, yeah, typically you're just going. So there is a chance that they could be getting that 4,000 volt, 4,000 volts of isolation, because maybe they're measuring it to the like the case of the capacitor instead of the internal isolation. You know, for example, they could be clipping both leads together and measuring it to like an aluminum chassis or not chassis, but aluminum shell in the capacitor. But normally they measure from one lead to the other. So I would, you know, ask them how they're making connection to the cap to get that result, because you're not seeing 4,000 volts out of a 50 volt cap. Not realistic.
Mm-hmm.
And then if you have any other questions, you can just email Chad at vitrek.com.
Yep.
Okay.
I'd be happy
Okay.
to answer that or talk.
Thank you very
And if
much.
you can't remember that, sales@vitrek.com works.
Mm-hmm. Okay, great. Thank you.
Thank you.
Thank you.
Any other questions from anybody? I think we've answered all the ones that were on the chat. Anybody else have need to open up their mic and ask? All right, well, Chad, thank you very much. That was very informative. Looked like people enjoyed it, and want to just thank everyone for their time. And Chad, any other closing comments?
No, yeah, thank you guys for your time. Obviously, it's a lot of information to cover. We really just skimmed the surface on everything. So if there's anything that caught your mind and you want to know more about that particular slide or that aspect of testing, don't be afraid to reach out. That's what we do.
And like we said, we have everyone's email. It will be emailed out along with the link to the website where you can see hear the actual presentation. All right, if that's it. We're 10 minutes overtime and 5 minutes below what I thought we'd go, so not too bad. And everyone have a great rest of the day, and as we say, stay safe out there.